This is the second day of data analysis for Physics 12. This video is going to be a lot shorter than the first one. This day we're just going to do a little practice of what we learned last day. So what's the story here? The apparatus below, a little helicopter with a block of wood, is used in an experiment on the planet Caprica. So we're not on the Earth, right? Planet Caprica to determine the mass of the bundle of wood. The helicopter is used to apply a variety of different sized rope tensions to the bundle of wood, and the resulting acceleration is recorded in the table on the right. Great. Be aware the value for G on Caprica is not 9.8 newtons per kilogram like it is on the Earth. First task says use the sheet of graph paper, the separate sheet, it's actually on the back of this page, to graph tension versus acceleration. Okay, first thing about graphs and the word versus. When people say this versus that, the item before versus is always the up axis, and the one after it is always the over axis, every single time in science. So if you look on your graph paper on the back side of this, sure enough, tension is on the up axis and acceleration is on the over. Okay, so it's always like that, up versus the over. Okay, so we're going to graph that. And I just want to remind you that the practice from Physics 11 was that you take the largest number you'd have to graph and divide by the number of boxes and then round up to something smooth. So vertically, you have to get to 35,000, and you must start at 0 for this. You can't say, well, I'm going to start at 20,000. No, I want you to start at 0. Got to get to 35,000, and you're going to have to go and count the number of boxes here on this page vertically. So biggest number divided by boxes and then round up to something smooth. Things that have like 1s, 2s, or 5s in them. Like 1, 2, 5, 10, 20, 50, 100, 200, 500. Okay, only those numbers. It's just much easier to find slope. You got to do the same thing for the across axis too for the acceleration. So go ahead and do that. The next part says, hey, rearrange the situation for F net equals MA. We'll get you started. We've got some tension going up and some value for mg going down, and it's accelerating upwards, so the tension looks like it's better than the mg. So as far as that rearranging goes, well, get your roll in here. We would say, all right, F net equals ma, so tension minus the mg is equal to ma, and the m's do not cancel here. And it looks like from this table, there are so many different values for tension and different values for acceleration. So you've got that as a changing thing and this as a changing thing. You just got to do a little rearranging. You want to make sure it looks like our goal, which is vertical axis by itself, then the equal sign, then the term with the across axis with the across axis at the back end, and then any y-intercept hanging on the end. So that's kind of the advice just to get rolling. When it says, hey, what does the slope of the graph represent? Don't say, hey, it represents the relationship between acceleration and that's wrong. That's what the graph represents. The slope of the graph represents that item that you'll find pressed up against the across axis. Okay, so it's just going to be like a one-word answer. Same thing with the y-intercept. And then you can find the mass of the bundle of wood and the value of G on Caprica. Once you have your graph drawn with these points, and you have added a best fitting line, you should never be going back to this table again. Those points are just to help you find the best fitting line, and then after that, do not touch them. Use your best fitting line and proceed from there. So that should give you enough advice to get you rolling on this second little worksheet, which you can complete, and you can ask me for some advice if you want, but then when you're ready, you've got to hand that one in.